Let's take a look at one last one. The Telectronics company manufactured a batch of 400 power supply units for computers. 8 of them are defective. If 3 of the units are randomly selected for testing, what is the probability that at least one of them will be defective? And they're also going to tell us without replacement. So first of all, we've got without replacement. We're trying to find the probability at least one is defective. When they use the terminology at least one, that means we know we're going to be taking the complement of something to make our lives easier, so we need to list out the sample space. So, the sample space, we were selecting 3 units. So it could be that all 3 were defective. It could be that only 2 were defective. It could be that only 1 was defective. Or it could be that none of the 3 were defective. Those are your options for the sample space. What they want in this particular problem is to look at the probability of finding at least one is defective. At least one being defective means all 3 could be defective, 2 could be defective, 1 could be defective. And that's what we're including in what we want. That's going to be too hard to find, so we'll find everything but that. Its complement, which is that none are defective. Well, let's work on that none of the 3 are defective. So let's find that probability instead. So we're finding the probability that we have all 3 are not defective. And again, we're going to stick the words "and" in the middle so we remember that we're multiplying. So let's find the probability one by one of these not being defective. Well, what's the probability of the first one not being defective? Well, there were 8 that were defective. So if there are 8 that are defective out of the 400, so there's 8 defective out of 400 total, then that means that the other 392 are not defective. So that's what I'm going to use, is that the fact that 392 out of the 400 are not defective. So that's my chances for my first selection not being defective. Okay, that's done. Now I need to move on to my second item not being defective. Well, remember we said without replacement. So I selected 1. Now I'm down to 391 that are not defective out of only 399 units now. Now I'm down to I've selected 2 now. So I can go ahead and check that one off. Now I'm wondering about my third one. Now for my third one, I'm down to only 390. Out of the 398 units that are left. Remember that I am multiplying as I go along. So going straight across the top, the 392 times 391 times 390 is, and I believe we did this one a couple sections ago and got this exact answer, 59,776,080. And on the bottom you'd have the 400 times the 399 times the 398, which would be 63,520,800. And let's do our division to find out what that is exactly as a probability. So 59,776,080 divided by my 63,520,800, which gives me 0.94. Again, remember that's what I don't want. That's that probability, 0.94. What I do want is everything else, which means I need to find its complement and do 1 minus what I found, which is the 0.94, which will get me 0.06. That's what I do want, my probability for at least one being defective. But I'm done. So I do get that this is time consuming and kind of an issue, but at least it happens in very specialized circumstances, and you're going to be looking for this keywording of at least one. That'll be your hint of I'm using complements. I need to list out the sample space. I will find the complement first because it's easier than to actually find the probability. I'll just take 1 minus that because complements probabilities have to add up to 1.